Good morning, dear students. Today I am going to discuss about the oxidation and reduction part of chapter 3 second paper. And before learning the oxidation and reduction reaction, you have to know about the oxidation number. Normally, the released or accepted electron by an atom during the chemical reaction is called oxidation number. Suppose potassium dichromate. The oxidation number of potassium is +1. Students, you have to memorize it. The oxidation number of potassium is +1 because during the formation of compound, potassium releases one electron from its last shell. That's why the oxidation number of potassium is +1. Otherwise, normally you have to memorize it that the oxidation number of the elements of group 1 is +1, and normally the oxidation number of oxygen is -2. Let the oxidation number of chromium is X. So, I can write here +1 into 2 plus X into 2 plus -2 into 7 is equal to 0. It is stated that in a molecule the sum of the oxidation number of the atoms is 0. That's why I have written here 0. So, it will be +2 plus 2x minus 14 is equal to 0. So, x is equal to +6. And if I calculate the oxidation number of any atom present in a ion, then I have to write here, suppose permanganate ion MnO4 minus. Students, I know that the oxidation number of oxygen is -2, and let the oxidation number of manganese is X. So, X plus -2 into 4 is equal to charge number. In case of ion, the sum of the oxidation number will be the charge number. X is equal to -1 plus 8. So, X is equal to +7. Dear students, that's all about the oxidation number. Now, you may ask me, sir, what is the difference between the oxidation number and balancing? The major difference between oxidation number and balancing is oxidation number is a digit with plus or minus, and balancing is a pure digit, and oxidation number of an atom may fraction, but the balancing of an element is the whole number. Those two are the major difference between the oxidation number and balancing. Look at the whiteboard. Ferrous chloride reacts with chlorine to produce ferric chloride. To make it balance, I have to write here 2 and 2. Students, we know that the oxidation number of chlorine is -1 and the oxidation number of iron is +2. As chlorine molecule is an elementary molecule, the oxidation number is 0, and here the oxidation number is chlorine is -1 and this is +3. So if we connect all those ions, I can write here ferrous ion. The oxidation number of ferrous ion is increased from +2 to +3 by releasing one electron. And students, all you know that the reaction in which the reactant releases electron is called oxidation reaction. So here oxidation reaction takes part. And again, the released electrons are accepted by chlorine, and the oxidation number of chlorine is decreased from 0 to -1 by accepting one electron. And students, all you know that the reaction in which electron is accepted by a reactant is called reduction reaction. So here reduction reaction takes part. And in the reduction reaction, the reactant which accepts electron is known as oxidizing agent. Oxidizing agent or oxidant. And in a reduction reaction, the reactant which releases electron is called reducing agent. So here Fe2 plus is reducing agent. Students, now I am going to show you the balancing of some oxidation reactions. Students, now look at the question. In the presence of dilute sulfuric acid, potassium dichromate reacts with ferrous sulfate. Students, now I can write the reaction according to the question. Potassium dichromate plus ferrous sulfate plus sulfuric acid. It is stated that this reaction takes part in the acidic medium, and if sulfuric acid is used as acidic medium, then the sulfate salts of all metal plus water will be produced. Here the metals are potassium, chromium and iron. So of course the products will be the potassium sulfate, chromium sulfate, ferric sulfate and water. Students, now I would like to mention some oxidation number of reactants and products. The oxidation number of chromium is +6, and in the reactants product side, the oxidation number of chromium in potassium dichromate is +6, and the oxidation number of chromium in the product side is +3. And again, the oxidation number of iron is +2 in the ferrous sulfate, and the oxidation number of iron is +3 in the ferric sulfate. It can be understood easily the oxidation number of iron is increased from +2 to +3 by releasing one electron. So here oxidation reaction takes part. Students, now I can write here half oxidation reaction. Here Fe2 plus, ferrous ion, releases one electron to form ferric ion. Students, I have written the half oxidation reaction from the main reaction. And again, half reduction reaction. Potassium dichromate. From potassium dichromate, I can write here dichromate ion and chromium 3 plus ion. Students, if you observe this half reaction, you will see that there are two chlorine atoms at the left side. So to make it balance, I have to write here +2. And here the chromium, the oxidation number of chromium is decreased from +6 to +3 by accepting 3 electrons. So one chromium accepts 3 electrons, 2 chromium accepts 6 electrons. Students, the number of oxygen atom at the left side are 7. So to balance the oxygen, I have to write here 7 molecules of water. And to make the balance of hydrogen, I can write here double number of H plus ion of water. So the H plus ion will be 14H plus. This is equation 2. To make the balance of the electron number, equation 1 into 6 plus equation 2. So I can write here 6 ferrous ion minus 6 electron is equal to 6 ferric ion, and dichromate ion plus 6 electron plus 14 H plus is equal to 2 chromium 3 plus 7 molecules of water. So students, it will be dichromate plus electrons are crossed out, so I can write here plus 6 ferrous ion plus 14H plus ion, 2 chromium 3 plus ion plus 6 ferric ion plus 7 molecules of water. Students, now I can put the spectator ions from this reaction. Instead of dichromate ion, I can write here potassium dichromate plus ferrous ion. So I can write here 6 ferrous sulfate and sulfuric acid. H plus ion comes from sulfuric acid, so I can write here 7H2SO4. 7 into 2 is equal to 14, and potassium sulfate plus chromium sulfate plus, as there are Cr2, that's why I need not write here 2 separately, and 3 ferric sulfate plus 7 molecules of water. This is the balanced reaction. Students, if you observe these half reactions, you will see that ferrous ion releases electrons. It means ferrous ion is a reducing agent. You can say ferrous sulfate is also reducing agent. And again, dichromate ion accepts electron. So, dear students, you can say potassium dichromate is an oxidizing agent. Students, now look at the whiteboard. I am going to discuss another balancing reaction. In the presence of dilute sulfuric acid, potassium permanganate reacts with ferrous sulfate. Then first I have to write the reactants from the question. Potassium permanganate plus ferrous sulfate plus sulfuric acid, as well as I can write here the salts of all metals plus water. Here the metal is potassium sulfate plus manganese sulfate plus ferric sulfate plus water. Students, now I would like to put some oxidation number plus 7 and the oxidation number of manganese in the manganese sulfate is plus 2, the oxidation number of ferrous sulfate is plus 2 and ferric sulfate is plus 3. So, students, half oxidation reaction is equal to ferrous sulfate Fe2 plus ion, ferrous ion releases electron to form ferric ion. Let it is the equation now 1, and half reduction reaction permanganate ion from potassium permanganate. I can write here permanganate ion Mn2 plus. Here the oxidation number is decreased from plus 7 to plus 2 by accepting 5 electrons, and there are 4 oxygen atoms at the left side. That's why I have to write here 4 molecules of water, and to balance, in order to balance the hydrogen, I have to write here double number of H plus ion of water. Let this is the equation 2. To make it balance the number of electrons in both of the equation 1 and equation 2, I can write here equation 1 into 5 plus equation 2. So it will be 5 ferrous minus 5 electrons equal to 5 ferric ion, and permanganate ion plus 5 electrons plus 8 plus ion, 8 each plus ion, Mn2 plus 4 molecules of water. So it will be permanganate ion, and the number of electrons are crossed out from both of the equation, and it is ferrous ion plus 8H plus ion is equal to 5 ferric ion plus Mn2 plus ion plus 4 molecules of water. Now I have to plug the spectator ions from this equation, permanganate ion. So the spectator ion is potassium, so it will be potassium permanganate plus 5 ferrous sulfate plus 8 4 H2SO4 plus is equal to potassium sulfate plus ferric sulfate. Students, to fix the 5 here, I have to write here 5 by 2, 2 will be crossed out. Then manganese sulfate, for Mn2 plus it will be manganese sulfate plus water, 4 molecules of water. Students, to make it balance, I have to write here half, and 2 are crossed out, then the potassium will be balanced. But normally we know that the fraction of atoms don't take part in the chemical reaction. That's why I have to remove those fractions. That's why in order to removing the fractions, I have to multiply the both of the side of the reaction. So I have to multiply it by 2. 2 potassium permanganate, 10 ferrous sulfate, 8 sulfuric acid, and 2 into half is equal to 1. Then 5 by 2 into 2 is equal to 5. So I can write here 5 and 2 ferrous, 2 manganese sulfate, and 4 into 2 I mean 8 molecules of water. Now if you observe this reaction, you will see that in the left side the number of atoms are equal to the right side the number of atoms. So students, this reaction is balanced, and if you observe the half oxidation reaction, you will see that Fe2 plus releases electrons, ferrous ion, ferric sulfate is reducing agent. And permanganate ion accepts electron, potassium permanganate is oxidizing agent. Potassium permanganate is oxidizing agent. So dear students, those two reactions are very important reaction, and those balancing reaction you have to learn by ion electron method, because it will be mentioned in your question. So no more today, students. Goodbye. May Allah bless you.